Good morning, everyone. No, Vedant, that was just a joke. But we could definitely implement it. Okay, so let's start now. So yesterday we were talking about these assumptions for projectile motion, and we just started discussing the terms. So we did the first one, that initial velocity is v0 vector. It's a tangent to the path, right? This green is the path again, right? The green that you are seeing is the path, right? Okay. And theta 0 is the initial angle, or the angle of projection. Angle of projection means angle at which it is thrown, right? So this object is thrown at an angle theta 0, right? Then the next term is time of flight. Time of flight means for how much time it remains in air. Okay, time for which it remains in the air. Okay, so that is called time of flight. So basically that means the time that is taken to go from, let's say, this point O to, let's say, this point A, right? The time that is taken to go from O to A, that will be the time of flight, right? Time for which the object remains in air, right? The symbol of time of flight is TF. Okay, the symbol of time of flight is TF. Then the next symbol, the next term that we're going to talk about is time for maximum height. Yes, capital T I think is compulsory. Generally, we write small t to indicate things like time and time interval and all that. Okay, this is something special, so I prefer we write capital T, right? Okay, so time for maximum height. What does that mean? Time for maximum height means in how much time it will reach from here to the maximum height over here, right? So the time to go from, let's say, from O to B, the time to go from O to B, that is called time for maximum height. Okay, so let me just mark that here. The time to go from O to B, that is called time for maximum height, or time to achieve maximum height. Okay, in tougher language, its symbol is TM or T, capital M, JM lokho M, no problem. Okay, TM, right? Time for maximum height, right? And then two very easy terms, two very easy terms. This height from here, this is called maximum height, capital H. Everyone, do not use any other symbol, you will get confused, right? Okay, from wherever you are throwing, From there it reaches this maximum height. Okay, so that's capital H. So the next term is maximum height achieved. तो achieved no spelling भूल गया, right? Is it right? I don't think so. Let me do a spell check. Is this right spelling? Achieved? ખબર હોય તો જ હા ના કેજો, પાછા એમને એમ નો કહેતા, મને ઉલ્લુ નો બનાવતા અમથા અમથા. No, it is IEVED. Yeah, that's right. IEVED. ઘરે બેઠા બેઠા છે ને હવે ઇંગ્લિશ એ બગડવા માંડ્યું છે. So that's the maximum height achieved. Right. Okay. H, right? Its symbol is capital H. Okay. Right. So now one last term, hopefully. This distance where it falls, the distance where it falls, right? So you have thrown it from here, or let's say kicked it from here, and it goes off and falls like this, right? So it will hit the ground here at this point. Okay, પહેલી વાર bounce થાય જ, I repeat, it hits the ground for the first time, that's it. પછી આમ ભલે bounce થાય, we don't care, right, about this part. Clear? Okay, why we don't care? Because there is a lot of complication involved to understand what happens over there, right? એ બધું આવશે આગળ, I think in chapter 6. Okay, right? So this is called range. R, range. It's a very easy word. Range means how far it falls. Okay, clear? It's called the range. So the next term is range. Range means how far it falls on ground. Okay, very easy. So it's called range R. All right. So these are the basic terms that are important. Okay, these are the basic terms that are important for all of you. ખાલી meaning સમજાવો જોઈએ, ગોખવાની કઈ જરૂર નથી. Please everyone try to understand the meaning. Simple English will help you, right? Range है displacement થાય, yes, range is one type of displacement, right? But you should understand that you can actually find displacement from O to even this point, right? Then that is not called displacement, that's not called range. I hope you understand. You can find displacement between any 2 points. Okay, but range is very specific. Okay, fine. So that's what we have. Now let's start deriving these values. Okay, under these assumptions. Can get assumptions? Were they on previous page? Yeah, here, right? No air resistance. Okay, we are considering that there is no wind also, right? We are saying that object is not going very high, right? So we can take G's value to be same, right? I hope you remember I told you yesterday that if you go very high, the value of G starts to decrease, right? So it's not like you are launching a satellite or from a or it's not like it's a rocket. Okay, or it's not even ICBM. ખબર ને ICBM શું હોય? Do you know what is ICBM? Do you know what is ICBM? Anyone? Okay, ICBMs are intercontinental ballistic missiles, right? They have ranges of about 5,000 or more, or about, some of the modern intercontinental ballistic missiles have range of 10,000 kilometers. એટલે ક્યાંથી ક્યાં ફાયર કરે ઇમેજિન કરી લેજો જરા. 5600 range was old actually. Okay, newer, last year, I think last year or before 2 or 3 years, USA has developed ICBMs which can fire up to range 10,000 kilometers, right? Okay, India and China both have ICBMs, right? So China's ICBMs are targeted to New Delhi, of course, and India's are for Beijing, right? But yes, I'm not saying there are many countries that have ICBM, પણ બધા કઈ ખુલીને બોલે નહીં, right? Okay. Anyways, it's not war yet, and it's not going to be war anytime soon. Okay. So let's focus on the physics. But you should, actually, you should understand that a lot of physics development has come because of wars, right? Whenever wars occur, people have to think of clever ideas, right? Okay, they have to understand how everything behaves. That is how physics develops, right? Okay, anyways, let's start deriving these things. Okay, now the first and very important and very basic thing to this whole topic is making a list of what we know. Okay, let's start. So as usual, let's say that there's one x-axis and there's one y-axis, right? Right now we are assuming we are just considering that we are throwing from ground or something, all right? So let's say this is x-axis along the ground, and let's say this is y-axis vertical, all right? And here is origin, and we are going to throw, or we are going to fire or do something from the ground, okay? And let's say this object is small, right? Okay, let's consider that this object is small. Okay, એટલે બહુ મોટું નહીં, પછી તમે એમ કહો સર આટલું મોટું છે તો not like that, right? So small means it's like you're possibly throwing 100 meters away, right? But compared to that 100 meter, this is like very small, maybe 10 centimeter in size. Okay, that's what is meaning of small. All right, so let's start. So if you are going to launch it or throw it from here, like I said, it's going to have an initial velocity v0 vector, which is at an initial angle theta 0, right? I hope that makes it clear. So it's like you throw a stone maybe at 30 degree, you throw a stone at 45 degree, or maybe you throw a stone at 90 degree, like that. Okay, so based on that, I can make two components. Now, making components is like livelihood of physics students. If you have got a vector, components are extremely important. This is that v0 vector, right? And here is the angle theta 0. I want to make its component. So can you tell me what will be its x component? Can you tell me what will be v0x? Everyone, use this triangle, use your trigonometry skills. Come on. Can you tell me what is this x component equal to? Come on, hurry up. Very good, Divya. Preet, give the complete answer. Ankita, your answer is not complete. Khali cos લખવાથી પૂરું ન થાય ને. Is v0x equal to cos theta? That's totally wrong, isn't it? This is totally wrong. It's impossible. It is dimensionally wrong. જો તમને ખબર પડતી હોય તો. Cos v0x? Falak, it is understood it is on I caret. It is going to be V0 cos theta 0, right? I hope that's clear. It is V0 cos theta 0, right? Because this length, see, when I draw an arrow, I have to write V0 vector. But actually, if I consider the length, then the length is only V0, right? The magnitude, and this is theta 0. So now I have to find the x component. So it's V0 cos theta 0. Is this clear, everyone? સાચું જ લખ્યું હતું, આ સાચું જ છે, ઓલું ખોટું હતું. People, I am giving you a warning. This is wrong. હવે આ ખોટું થઈ ગયું. I hope that is clear. Okay, because this thing on left side is not a vector. બરાબર ને? એને છાપરું નથી. It does not have that uniform, right? It is not wearing the uniform, right? So this is wrong. Now it is correct. I hope that makes sense. Okay, so V0x is V0 cos theta 0. Right now, just like that, I would like to know what is V0y. I would like to know from all of you what is V0y. આ બધાને આવડવું જ જોઈએ. માથા પછાડો ગમે કરો, આ નહીં આવડે તો ફિઝિક્સમાં પાસ નહીં થાવ, હું તમને ગેરંટી આપું છું. I want everyone to answer. There are more than 90 students. હજી મને 10 જ આન્સર મળ્યા છે. You don't need to answer twice, people. Don't inflate the numbers. Let everyone answer. નામ લઈને કહો. ધ્રુવ, આયુષ દેસાઈ, અનુજ પટેલ, અર્કન, આશીષ, પૂર્વા, દર્શિત. I don't have your answers. દીક્ષિતા, દિયા, હર્ષલ, હિમાદ્રી, ઈરમ, ક્રિનલ, વૈદેહી, રાઠોડ નંદિની. Where are your answers? Sejal. Okay, Ayush. It is going sorry, it is going to be V0 sine theta 0. One and only explanation this time. Okay, આના પછી બીજી વાર આ શીખવાડીશ નહીં નહીં ને નહીં જ તે. This is V0y. So if you want to find V0y, you have to take sine theta because it is opposite upon hypotenuse. So opposite is V0y divided by hypotenuse is V0. That's why V0y is equal to V0 sine theta 0. આવી રીતે find કરાય. Clear? Okay. I hope everyone has learned it, right? So this is it. So now we have got the initial components, the components of initial velocity, right? We have got components of initial velocity. Now next, components of acceleration. Now again, let me tell you, acceleration is constant here, acceleration is constant here, and in fact it is equal to minus gj caret, because Earth is going to attract this object, whatever you are throwing, maybe stone or a ball or something, right? Earth is going to attract it, and I'm sure all of you remember that Earth always attracts the thing downwards, correct? Okay, and with how much magnitude of that acceleration is g. We learned all this in previous chapter. Okay, magnitude of that acceleration is g and the direction is downwards always, right? So is this clear to you? Is this clear to you? Okay, now let's write this. Keep that in mind and tell me both of these values. Come on people, hurry up. Can you tell me both of these values? Hint, compare it with this. I hope you remember that we can always write any vector like this. Compare this with this. Don't compare like Hansa. I've got only one answer. Come on people. શું લખે જયકિત તું આ? What you're writing doesn't make any sense. Capital A nahi follow. Okay, but I think that is autocorrect. No Raj, no Rahul. What? Prasham X equal to A? વાહ શું વાત છે. It's not correct. No Rahul, it's wrong. Asu J caret option I caret Ria, come on. No Dikshita, not correct. I want both the answers. AX AY, come on people, look at this. AX AY, we want both the answers. No Ankita, it's not right. દર વખતે એવું ન કરવાનું હોય. Okay, I want to warn all of you, please તમે એવું ગોખીને નહીં બેસો કે AX એટલે A cos theta અને AY એટલે A sin theta. આવું ગોખીને નહીં બેસવાનું. Do not mug it up. Okay, please don't mug it up. It doesn't help. You should understand the context. You should understand the situation. અહીંયા જો, what did I tell you? I said compare this. Are you listening? I said compare both of these and tell me what is AX, what is AY. No, Vedant, totally wrong. I said compare both of these. Yes, the correct answer is AX is 0 and AY is minus G. અરે અહીંયા લખ્યું તો છે બાજુમાં, નથી લખ્યું હે? તમે વાંચો તો ખરા. આ નથી લખ્યું અહીંયા 0 I caret minus G J caret લખ્યું છે ને, એ નથી લખ્યું? Yes or no? Clear? I want your answer. Clear or not clear? If it's not clear, I'll have to explain it again. Is it clear? Okay, some people are still having problem. Let me explain it again. અરે ભાઈ કઈ અઘરું નથી કરતા. એ તો ખબર ને કે દરેક વેક્ટર ને આવી રીતે લખી શકાય in form of components. And here we know that this is equal to minus G J caret. And I નથી લખ્યું, it means it's 0. It's like if I tell you that from the market I have brought 10 apples. Okay, then do you think you will ask me, sir, you have brought how many oranges? Of course I brought 0 oranges, right? Okay, I hope you understand. When we are not mentioning it, this is going to be 0. Haji not clear? So now compare this and this. So what is AX? Clearly AX is 0. And what is AY? Minus G. આમાં શું અઘરું હતું? આમાં ખબર નહીં તમને લોકોને શું અઘરું લાગી ગયું. ઓકે, બરાબર ને? I don't think now there is any problem. થોડુંક સાંભળીએ લો. ઓડિયો ક્લિયર ન હોય તો કહી દો. Only watching doesn't help. ઇયરફોન લગાડી દો જો ન સંભળાતું હોય તો. બરાબર. Okay, So now this is a table that you should definitely know and understand. અને ઊંઘમાંથી ઉઠાડે તો એ આવડવું જ જોઈએ આ table. Okay, these four values are very important if you want to understand what is projectile motion and how it works. Okay, these four values are very important, everyone. Okay, and they are very easy also. In my opinion, they are extremely easy to do, right? And you know, my what I've noticed with lots of students every year is that suppose A is used to understand B, B is used to understand C, and C is used to understand D. And then when you have a doubt with D, when you have a doubt with D, you should actually understand that there is a problem with B or C, right? તમને B or C નહીં સમજાતું હોય ને એટલે તમને છે ને હવે D નથી સમજાતું. You should understand that very well. Okay, so please try to understand the link. Okay, in physics there is nothing that is standalone. Standalone એટલે એવું ફિઝિક્સમાં કંઈ હોતું જ નથી કે હા બસ હવે આ બી નો આવડ્યું તો વાંધો નહીં આગળ બધું આવડશે, એ ભૂલી જ જવાનું. ઓકે, બી નહીં આવડે ને તો આગળ બીજી 50 વસ્તુ લાઈનમાં ઊભી જશે તમને હેરાન કરવા. Yes, nothing is independent in physics except motion on two axes, right? Motion on two axes is independent. Okay, બાકી કઈ independent ન હોય. Right, so keep these values in mind and let's do our calculations. Diagrams are very important. મને શોખ નતો તો બે ત્રણ વાર ડ્રો કરવાનો, દર વર્ષે હું કરું જ છું. It's necessary, right? If you are lazy with diagrams, you can forget this topic. So it says that suppose we throw something at an angle theta 0, right? At an angle theta 0 with speed or velocity v0, right? Like this. Okay, like this. So now if you want to find out, હવે આ લખજો બરાબર, velocity components. If you want to find out velocity components at time t after launch, okay, launch or throw. Okay, so basically I'm asking after time t, that is when time is equal to t, what will be Vx and what will be Vy. See, magically V0, I'm not writing V0 now. Why am I writing Vx? Because we are talking about at a time t. We are not talking about initial. I hope that is clear. We are talking about at a time t, right? We are not talking about initial. So we are not writing V0. So now, if you remember, I told you that acceleration here is constant. It means we can use what? If acceleration is constant, we can use, if acceleration is constant, we can use are you all there? જીવો છો? જાગો છો? If acceleration is constant, we can use, હા નહીં, આન્સર આપો. What can we use? If acceleration is constant, what can we use? Some of you are saying G. અરે G, પાર્લે G નથી use કરવાનો. We can use equations of kinematics. એ તો યાદ જ નહીં આવતું હોય. If acceleration is constant, we can use equations of kinematics, right? Okay, so for Vx, all right, for હવે બે કોલમ બનાવી દઉં, એક કામ કરીએ, બે કોલમ જ બનાવી દઉં, one for x, one for y. Okay, so we can do respective calculations over there, એટલે તમને easy પડે. This is x party and this is y party. Okay, a difference between x and y નથી. So Vx equal to, okay, if I want to find Vx, which equation of kinematics should I use? 1, 2 or 3? 1, 2 or 3? Come on people. 1, very good. So let's use it. Vx equal to v0x plus axt. I hope this is clear. અને તમને લખતા આવડવી જોઈએ હવે જાતે. Okay, put the values. Come on people, put values. Put values. What is v0x? What is v0x? So what do we get? Final answer. Final answer. Come on people, I want final answer here. Tell me what should we get? Final answer. Final answer everyone. Okay. Yes, the final answer is going to be v0 cos theta 0, right? Not capital. Yeah, v0 cos theta 0. Okay, that's it. And do you see that this is actually a constant? It does not depend on time. This is actually a constant. It does not depend on time, right? Okay. આમાં ક્યાંય t આવ્યું જ નહીં ને, right? You can put t equal to 10, you can put t equal to 1, you can put t equal to 2, doesn't matter. Here you don't have t. And this is not a surprise. This is not a surprise. Can someone tell me why it happened like this? Can someone tell me why it happened like this? Why? Maths nahi, physics no answer જોઈએ છે. Physics. Why it happened like this? Yes, very good Priyansh, very good Divya, very good Rehan Khan. Well done people. Looks like you all are going to be stars in the world of physics. Jaldi pakdi લીધું તમે. Very good Dharmi, well done. I've got 4 answers and 4 answers have been perfect. Well done people. Others, come on, give it a try, give it a try. Hurry up. No Ayushi, no Jadav Chintan, no Kavya, no Vaidehi. Yes, Preet, well done. Angle theta is x-axis. Vandan, what are you writing? No, Ria. Acceleration is constant, so velocity constant no આવે. એવો કઈ law નથી શીખવાડ્યો મેં. If acceleration is constant, velocity is also constant. વાહ, એવું હોય? Think about it carefully, people. Come on, think about it. The correct answer is because ax is 0. I hope all of you remember that if acceleration is 0, then velocity is constant, or vice versa, right? Velocity is constant. That has same meaning as acceleration is 0. Angle does not remain same. No, totally wrong. Angle will in fact change. તો જ આ turn થાય ને. I hope you all are realizing that the angle will change, right? As time will pass, the angle will change. You are going to get confused. I know, Vedant. The way you have put the question and I had to answer it, you are going to get confused. Acceleration 0 કઈ રીતે? કોણ છે આ? સાહિલ હે? અભી હાલ આ સમજાવ્યું હતું ને આ શું કીધું હતું કે આ વેલ્યુઝ યાદ રાખવાની? ક્લાસમાં ध्यान રાખો. આ શું લખ્યું છે? ax equal to 0 હે? હમણાં જ સમજાવ્યું હતું ને કે a નહીં આવડે તો b નહીં આવડે તો c નહીં આવડે તો d નહીં આવડે. You are getting a very good example, right? You are asking me about d but you don't know about b, so that's why you are having a problem. Okay, so vx is constant because ax is 0. Okay, I'll tell you, this is again very important to remember, right? This is important to remember. Right, now let's do the other party thing. Vy. Okay, this time let's do it for vy. Come on people. Same method. Give me final answer. Give me final answer. I am giving you 1 or 2 minutes. All right, 2 minutes for it. Give me final answer. I want final answer after putting all the values. No, most of the answers are wrong. Prima Kavya, your answer is right. Well done. Divya, your answer is right. Very good. Yes, Dharmi, it is right. Dia, it is right. Jaiket, it is right. Priyansh, it is wrong this time. Ankita, it's correct. Well done. Falak, it's right. Ria Singh, not correct. Gracie, you have given an answer. Let me check. Uh, no, Gracie. Small mistake over there. Okay, I'm writing the final answer now. The final answer is V0 sine theta 0 minus GT. Is this clear or should I explain? Is this clear or should I explain? No, Arkan, your answer is wrong because you wrote J caret. There is no need of J caret because as I mentioned earlier, V0y, sorry, AY is equal to minus G. AY is not equal to minus G J caret, right? Okay, that's why Arkan, your answer is wrong. All right, does anyone want me to explain this? Basically we have just put the values, right? બીજું કંઈ કરવાનું નથી એટલે જ મેં તમને આપ્યું હતું. બહુ અઘરું હોય તો હું તમને આપું જ નહીં. Okay, so this is the other one. And see, I'd say you remember it if you can, but otherwise also it's very easy, right? I think you can understand that this is just one step away from equation of kinematics, right? It's just one step away from equation of kinematics, right? Okay, there has been a request to explain. I'll just do it very fast. First of all, we use the formula V0y plus AYT, right? And then we put values, right? We already have the values. V0y is V0 sine theta 0 and AY is minus G. So let's write the value and we get this answer. All right, so that's it. Okay. All right then. So V0 sine theta 0 minus GT. Now, is this a constant? I'm asking you, is this a constant? Yes or no? Is this a constant? Is this a constant? No, because you can see there is t in it, right? As you put different values of t, the value of Vy will change. So it's not a constant, right? And you could also say that because there is Ay, which is minus G and not 0, right? If acceleration is not 0, the velocity cannot be constant, right? Okay. So t is, because t will change, that is right from maths point of view. Okay, it's correct. But from physics point of view, this is the answer, right? I hope you will understand it both the ways, right? Both are important. You should understand it mathematically. You should also understand it using physics, right? Okay, now next we are going to talk about delta x. Okay, હું તમને કહી દઉં અને પછી તમે વિચારવા માંડો. Meanwhile, I'll erase my board. Okay, think about delta x. Think about delta x, people. Come on, think about delta x now. So we did it for velocity, okay, on both sides. Now it's time for delta x. Can you tell me what will be delta x? Can you tell me what will be delta x? Here again, you can use equations of kind. Delta x is not range. Kon boilu? Delta x is not range, Dharmi, because you can find delta x at any time t. When it falls and you find delta x, that is range. But here, suppose when the ball is in the air and you want to find out what is displacement at that time, then it's not range. Okay. No, Priyansh. Awesome. People, you just have to use one of the equations of kinematics, right? Okay. Okay, I have not got your answer, I think. Yeah, it's right. It's right. It's right. Okay, here is the final answer. Method જ કહી દઉં ચલો. First of all, we use equation. So v0x t plus half ax t square. All right. This is the equation. But ax is 0. So if you put all the values, then you will finally get your answer as delta x is equal to v0 cos theta 0 into t. Clear? You'll get delta x is equal to v0 cos theta 0 into t. Right? Okay, because this is 0, because ax is 0. Okay, now see, actually this is very easy to understand in a slightly different way also. Do you see that on x-axis or x components, there is no acceleration? So velocity's x component is constant and it is equal to v0 cos theta 0. So do you realize that if velocity is constant, you can easily find displacement as simply velocity into time interval. I hope that makes sense. Right? This is very easy stuff, isn't it? You can always find displacement as velocity into time interval because of this. So this will be equal to v0 cos theta 0 into t, as easy as that. Right? Okay. So this is another way to do it, right? You can use it, you can use whichever way you like. બધું ઈ જ છે, છેલ્લે તો ઈ જ answer આવે. Right? Two correct methods, okay? Not coincidence. Two correct methods. Now time for this one. Come on, delta y. 1 minute to get to the final answer, everyone. 1 minute to get to the final answer. Yes, Ayushi, for x only. Agreed. હમણાં y કરશો એટલે બધું ખબર પડી જશે. For y now. Come on. No, Arkan, your answer is wrong. No, Ria. Dimensionally wrong. Ria Singh. Vaishnav Ria, your answer is correct. Yes, Raj, that's right. Rohan, slight mistake. Look, it's right. Divya, it's right. Okay. Well, the class seems to be divided. Some of you are getting right answers, some of you are getting wrong answers, nearly 50-50. No, Gracie, you made a small mistake. People, be careful. Don't make silly mistakes. Don't make silly mistakes. Yes, Kavya. Yes, Ankita. Arkan, your answer is wrong. Okay, now I'm writing the answer. All right, I'm writing the answer, and the answer is going to be, well, the steps. First of all, v0 yt plus half ayt square. This is the formula. Okay, and now we put values in the formula. So we get delta y is equal to v0 sine theta 0 t. All right, its value. And ay is minus g. So plus minus will become minus. Clear? I don't think this will bother anyone. Again, everything comes from that table. Only 4 value માં જ રમવાનું છે. Right? I hope all of you understand that those 4 values are very important. એનાથી જ બધું થઈ જાય. Okay? All right then. So let's just pause over here for a minute and understand what have we derived so far, right? થોડુંક એનો physical meaning સમજાવો. અત્યાર સુધી થોડુંક maths જેવું કર્યું. See, what we have derived is, listen to this carefully. Suppose that after here you throw it at time t equal to 0, and let's say this thing reaches here at time t equal to t. Suppose at this point A, okay, let's call that point A. Then what is going on is that at this point when it reaches at A, how much is the horizontal displacement? That is delta x. Is this clear? The meaning of delta x? How much is the horizontal displacement, that is delta x, in a time t or in a time interval t? Meaning clear, everyone? And similarly at that time, how much is the vertical displacement? This one. Okay, so actually let me just write here. This one, that is delta y. Clear? How much is the vertical displacement? That is delta y. All right. Okay, now what about Vx? Now this is very interesting. Here it would have a velocity again tangent to the path. આવી રીતે હશે ને velocity. Is this clear? This is the velocity vector. I repeat, this velocity is tangent to the path. It is velocity vector. Now this velocity vector, every vector has components, right? So let me take this out of the diagram. અહીંયા બહુ ખીચડી થાય છે પછી. It's very clumsy. You'll not be able to understand what I'm drawing. So let me just take it out here. Okay. So I'm saying that this is the path on which it is moving, right? This is the path on which it is moving. Suppose here it has reached, and so this is its velocity vector, right? So this velocity vector will have two components. Again, to make components, it's best to trap it in a rectangle. I hope you remember that. Okay, chalo. All right, we have trapped it in a rectangle. So now this velocity vector has two components. One is x component, Vx, and the other is y component, like this, or here, whichever way you like. Okay, a rectangle. Is this clear? Right? So you see that initially, let's draw initial picture. Initially, the velocity vector was like this, right? And it was making an angle, theta 0. હવે તો angle એ બદલાઈ ગયો. Do you realize the angle is changing continuously as this particle, the angle is changing continuously as this particle goes from here to here to here to here to here, right? Okay, so the angle itself would have changed, right? Angle itself would have changed. So anyways, what I'm saying now is that this angle with x-axis, this is going to be some angle theta. Is theta equal to theta 0? No. Clear? Theta is not equal to theta 0. Clear? Theta is not equal to theta 0. So gradually the angle will change, but yes, see, suppose you throw it at 30 degree. Let's say we throw it at 30 degree. So once you throw, this is fixed, right? You cannot go back in your history and erase it, right? If you throw it at 30 degree, then theta 0, its value becomes fixed. That you can't change. But yes, gradually as time passes, value of theta will change. I hope you are not getting confused between theta and theta 0. They are two different animals, right? They are two different things. Okay, they're not the same. v vector is the velocity at time t. All right, and theta is the angle, okay, of velocity at time t, right? Okay, so this is what we have been talking about, right? So as time will pass, the velocity will continuously change in magnitude and in direction also. Let me tell you, velocity will continuously change in magnitude and in direction, right? Okay, so speed will change, direction will change, lots of things are changing, right? Now over here, I'd like to show it to you actually. Okay, I think I have it ready. Okay, just give me one moment, I will confirm it. Okay, just give me one moment. I have an animation for you ready. Okay, I would have made it last year, I think. Oh, all right, I hope I can find it now. Documents. Okay, it's there, thankfully. Okay, yeah, found it. Found it. Projectile motion. Okay, so I'm sure you can't see it on the screen yet. Just give me one moment. I'll enable that. Okay. Yeah, I was going to show something else also. Right now you see this. Okay, I was going to show you about 3D vectors. Uh, okay, share screen, how to do that. Yeah. All right, can you all see something on the screen now? Okay, right. So here is our projectile ready to be thrown. Okay, we are going to throw it from the ground. નીચે અડી જા. એકવાર એને પાડી દઈએ પહેલા. Okay, so from the ground we are going to throw it, right? Okay, so and we are going to throw it with this velocity v, which is here, right? Right now I have set the angle to be 50 degrees. As you can see, I hope you can read it here. This angle is 50 degrees. Okay, right? So we are going to see what happens to its velocity as it moves, right? What happens to its velocity as the earth attracts it will make a projectile motion. Okay, okay, so did you all see? I can actually play it back, right? Let's do it slowly. I want all of you to focus on this arrow. Okay, do you see this velocity arrow, right? Okay, it is indicating its velocity. You look at its velocity vector, all right, and I've slowed it down. You see the vector grows small. Did it become small? Did you notice that? Look, it's quite big here. And gradually it becomes small, right? So, okay, why did that happen? It's because I think all of you have this natural idea that as anything would go higher, as anything goes higher, it would become slower, correct? Right? It becomes slower. So when it becomes slow, it means its speed is less. And speed is less means magnitude of velocity is less, right? Magnitude of velocity is indicated by the length of the arrow. I hope you remember that the length of the vector indicates magnitude. Do you remember that, everyone? Length of the vector indicates magnitude. So that is what is going on here, right? So as it goes higher, the speed is decreasing, okay, and the magnitude of this velocity vector is decreasing, so it's getting smaller in size, right? But not only that, there's one more thing to observe: the angle. There is one more thing to observe, and that is the angle. So what I'm going to do is I'll just draw some horizontal lines. Okay, over here it's like 50 degrees, right? So let's allow it to play. Okay, let's play it. What happens further? Okay, now let's draw one horizontal line. You see, over here the angle was bigger, right? I hope you can already notice it, but let's try one more time. Now if you draw one more horizontal line, you see the angle is becoming very small. Do you agree with me? Right? Earlier the angle was quite big. Now it has become pretty small. Right? At one point of time, in fact, it would become zero also, right? At one point of time, it would become zero also. Let's play it further. You'll see. Okay. That's why I'm doing it slowly so that I could, stop it at a proper time. How to set speed? I forgot that. Yeah. Okay. Have a look at this now. It's almost become horizontal. See, I'm drawing horizontal line because this snaps to the horizontal line. See, right? This has become horizontal. So you know what point is this? This is actually where it has achieved the maximum height. This is where it has reached maximum height, h. Right? And now what's going to happen? Do you remember that sentence? Object moves in direction of velocity. So what was happening is all these points the velocity was upwards. So the object was going up. Now over here the velocity has become horizontal. So now the object is not going up. It has stopped going up, right? And now gradually, because of Earth's attraction, the velocity, because of the acceleration, the velocity is going to turn. So if I play it further, you're going to see that the velocity will now come downwards at an angle. See, do you observe this? The velocity's angle has changed, right, downwards. Is that clear? Right? The velocity's angle has now changed downwards, right? So what's going on is that now it is making an angle here. Instead of making an angle upwards, so like positive angle, instead of positive angle, now it's making a negative kind of angle, right? So now this object has started to fall down. That is, this object is moving in this direction, right? But again, because of gravitational force and gravitational acceleration, because of g, because of the acceleration, it's not going to allow it to move in a straight line. So let's do one magic. Okay, right? Let's just do one thing. Let's turn off gravity. Here there is a nice facility. If I turn the gravity off, it will just keep on moving in a straight line. Okay, observe this. All right, you can clearly see, right? So sorry, I'm not used to this. Just a minute. Okay, yeah. So you can actually observe that this is going to move in a straight line because I have turned off gravity. right? See, this is not moving like a projectile, it's moving in a straight line. That's actually cheating because we have turned gravity off, right? So if we just go back again and turn it on, you see it will follow the usual. See, you understood this? And it will fall down like this, right? After that it will bounce, but once again we don't really care about what's going to happen when it bounces, right? We only care up to this point. So you see clearly that this distance is called nothing other than range r. Okay, this is called nothing other than range. Okay, so it's right. Suppose gravity was off all the way from start, then we would never get this projectile motion, right? Again, we will talk about that. All that is fun to do, right? But I want all of you to understand a few particular things. I know that it's time, but yet I'm sure you don't have a problem today, at least because you are seeing something new today, right? So here you see, if I would draw its components, right? See, this is the velocity, right? And if I draw the components of velocity, let me just set it like this properly. Okay, if I draw the components of velocity, then I would get one component over here, that would be x component, and I would get one component here by drawing rectangle again, that would be the y component. I hope you understood what I've done, right? So you see here the y component is quite small, but the x component is pretty big, right? So if you allow it to play, right, if you allow this thing to continue further, you're going to see, actually I should not have zoomed out. Okay, yeah, fine. If you allow it to play, let's see what happens after a while. Okay, let's allow it to play, and now let's go over there, and now let's draw the components. You see it doesn't match, right? You see it doesn't match in y, it matches in x. You know why? Because x component remains constant. I hope you learned that. But you look at y, the new y component is all the way from here to here. Oh, okay, sorry, I don't think you'll be able to see that. Right? The new y component is all the way from here to here. Do you see that? Right? So that is Vy is changing. Vy is changing, but Vx is not changing. Yes, y component is getting bigger now. First it would get smaller, then it would get bigger, right? So, but the x component never changes, right? That is because on the x axis it is constant, right? The x component of velocity is constant. So this is how the angle is changing, and I'm sure you realize why the angle should change, because tan theta is Vy upon Vx, right? Tan theta is Vy upon Vx. So if the numerator keeps changing but denominator remains constant, if numerator keeps changing but the denominator remains constant, obviously theta should change. આ બધું maths, બરાબર ને? આ બધું maths સમજાય, right? Okay, but physically or using physics reasons, you could say that ax is 0, so that's why vx is not changing, or it is constant, right? But ay is not 0, it is minus g, that's why vy keeps changing. Okay, Vy keeps changing. All right. So that's the whole crux of the matter, right? That's the whole understanding of how projectile motion works. Okay. So hopefully you will be able to remember all of this. બહુ બધું સમજાયું છે મેં તમને, right? આવું imagine કરવાનું છે. See, the main thing is people, why am I showing this to you? So that you can imagine this. તમારા માઇન્ડમાં આવું એનિમેશન થવું જોઈએ જાતે જાતે, right? તમારે કઈ સોફ્ટવેરની જરૂર નથી. Your mind has all the softwares required, right? You should be able to imagine exactly the arrow like this. આ કેવી રીતે આમ જાય. Okay, by the way, what shape is it making? આ shape ને કયો shape કહેવાય? Is it a circle? What shape is this? What shape is this? આ જે path દેખાય ને, I hope all of you can see this is the path. બરાબર ને? આ path છે ને, the object went like this, this is the path. What shape is the path? ઓકે ના એ બમ્પ જેવું છે એ બરાબર, પણ એને મેથ્સમાં એને એક્ઝેક્ટ શેપ શું કહેવાય? It is called a parabola. Right? This shape is called a parabola. Okay, not semicircle. Dhruvi, Dharmi, not semicircle. Right? Curve પણ કયો curve ઉદય? Curves are of so many shapes. બરાબર ને? આને curve કહેવાય. તો આવું તો ન બને. So, right? So this is called a parabola. Please remember that. All right. So with that much, we will wind up this discussion today. We will continue with it tomorrow. ના હાઇપરબોલા એવું ન હોય. પેરાબોલા આમે હોય ગમે એમ હોય, બટ ધીસ ઇઝ અ પેરાબોલા. જોઈને ન ખબર પડે whether it's a parabola or hyperbola. All right? Okay, goodbye everyone. See you tomorrow. Yes, Preet, you raised hand. Do you want to ask a question? All right. Goodbye everyone.